Hello, myself is Pritesh Kumar Mahajan, and today I am giving you the topic presentation for the Mac operating system. Mac is the operating system which is uh, controlled and developed by the Apple Corporation based on the California in the US. So basically, the operating system is the system software which manages the computer hardware and the software resources, and it provides the common services for the computer program. And for any computing system, the major and essential component is the operating system, which allow the user to work it programs, and that program internally works with the hardware to display the final output or to make the program run. And let's take to the outline. What topics we are going to cover in this is the architecture. The second is the process and the memory management, and the third one is the file system management. Let me go through the each of the word in a brief so you can have the basic concept what is the meaning of the architecture, process, memory, and the file system. In the computing system, the main role is also the hardware, and it depends on how it is being designed. Earlier they were the 32-bit of the computers. Nowadays people are using the 64-bit computer. So what's the meaning of this bit terms? So it depend on the architecture you select. It's and it's based on the microcontrollers like 8086, 8085. These are the all electronics terms, but we just want to make sure this the architecture is of the hardware. There is no architecture with the operating system. Architecture term is used for the hardware, and under above that the operating system works. The second is the process and the memory management. Whenever you are executing any program or any, for example, if you are opening any browser tab in the browser window, internally it's a process in the computer system, and one program may have various processes, and processes is some sub component part of the program. And to run that process, basically the program first need to be come into the main memory, because CPU can only access the main memory without the intervention of the other hardware component. So it can directly come to the main memory and it directly execute the program, and internally it becomes a process with the timeline. And memory management is in the computer, there are two types of the memory: the random memory and the ROM. Just go through the terms in a very short. A random access memory is a volatile memory, or you can say it's a temporarily storing the data, which needs by the CPU frequently. And read-only memory contains the data which the end user cannot modify. Uh, Take it in this way: if computer starts basic, internally it operates the basic BIOS system. For that, the software would be the specific, and you cannot modify that software. So, and the second, there are also the types of the secondary storage, which is the hard disk drive at the end user. And third component is the file system management. Is whenever you are storing any, whenever you are writing or writing and saving the file, there are the various extensions in the operating system for the editors, it's a text file, Word file. But for the operating system, there are the you can say NTFS, FAT32. These are the various allocations or types of the file system. Let me go through the next slide to describe about the this all these terms in a brief manner. These are the Mac operating system facts. It it was developed by and being developed by the Apple Incorporation. And first, it was the GUI based OS. GUI is a graphical user interface. Uh, it's it's a the part like when you switch on the computer, what the components you are seeing on the desktop, it's a GUI, and when you are clicking or maximizing or minimizing, it's a GUI. That's called the graphical user interface, and it also plays a important role in the operating system because the main goal of the operating system will be how it will be easier for the end user to interact with your the system and to run that program. These are the some history about the Mac OS. It was first introduced as a system software in 1884. Then finally it renamed as a Mac OS in the 1996. And from 1984 to 2000, it was a classic Mac OS. And 2001 to till present, it is generally called as a Mac OS X. And the current version is V 10.9 Mavericks. And in the 1994, it is being an integral to the original Macintosh. Previously, it was the call as a Macintosh system also. Here is the overview of the Mac OS. And in 1996, Apple purchased this next computer with the thought of using its OpenStep operating system as the basis for the next generation Mac OS. And the Mac OS X architecture can component based model. Component is the internally it's a small program which is you are seeing in the screen. For example, the calendar, the App Store, the iTunes. You can build your operating system based on the component based also. Component based. And this is the layered and the component based architecture. The main advantage of the layered architecture is the lower layer component provide services to the upper layer. And one major advantage is the modularity, that if you modify any your program, it will limit it to that portion. You don't need to change the each module associated with it. You just need to test the whatever modules are in sync with that particular module which you change. You can see this Aqua, Classic Carbon, Cocoa, Java, Quartz, OpenGL, Darwin. This is the main architecture of the Mac OS. The lower level, as I discussed in the previous, such as the Darwins and the QuickTime, provide the foundation of the technology, and this architecture specific to the Mac comprises the 9 components on the higher level. If you look at the figure, the at the very bottom there is an hardware, open firmware, and the bootloader on which the kernel module lies. Kernel is also an important part of the operating system. And upon that you can build your core services, application services, and these are the various application environments as mentioned in this BSD, Carbon, Classic, Cocoa. These are the application environment. In they also use the current latest technology, the JVM and the JRE. Aqua uses the Quartz imaging engine that's written in the Cocoa, Carbon, or Java can access the capability of the Aqua GUI. The second is the classic that's called as a blue box in the repository implementation, enabling the existing macOS application to run under the macOS. The whenever you are designing or testing the computer operating system, the main feature you need to check is the compatibility. By this term means is whatever software you designed previously, it should be run on the next or the latest operating system you are designing. It should not be like this specific to the specific to the this one specific to the whatever system you are currently designing. That's So these are the just brief introduction for the Cocoa, Java, and Mac OS is a player in the Java development and deployment arena. Quartz. That's Apple new 2D imaging framework and the Windows Server based on the PDF format. These are the architectures models which are briefly described. Now the main component of the core part of the operating system, the kernel, is called as a XNU in the Mac OS. This term varies from OS to OS. The components are the Mesh, BSD, IOKit, and Platform Expert, Libcon, and Libsa. What is the meaning of the Mac? The legendary architecture originally originated as a research project at Carnegie Mellon University in the mid of the 1980s. The BSD subsystem is a part of the kernel. This kernel concept comes from the main Linux operating system and its primitive multitasking, including the kernel threads. POSIX threads on the Mac OS X are implemented using the kernel threads. Other features: protected memory, virtual memory management, inter-process communication, interrupt management, real-time support, kernel debugging support, console I/O, and so on. The next is the BSD. That's its the full name is Berkeley Standard Distribution, and that uses the FreeBSD as the primary reference code base for the Linux operating system. Uh, there are too many operating systems nowadays which are based on the Linux. Uh, for example, Ubuntu, Gentoo, Fedora, the Mac OS. These are the various Linux operating system, but it internally uses the base code of the Linux is the BSD that was developed by the um, California based the university, and the Darwin 7.x Mac OS X 10.3.x uses this free BSD, and BSD runs not as an external or the user level server, but it's the part of the kernel itself. So the kernel part of the any Linux operating system uses this as a code base, and some responsibilities that includes process models, user ID permission. User ID permission is in the Linux is whenever you are creating any file, you can have the privilege like who will be able to edit, who will be able to read, and who will be able to only the write. So these are the various permission: read, write, and update it. The basic security policies: POSIX is a POSIX based API BSD system BSD style system calls, TCP/IP stack, BSD sockets, crypto framework, various synchronization and mechanism, and so this also the main part of the operating system that is mentioned over here. uh, Now it's in the IO kit, input output kit, and the full form is, it's an object oriented device driver framework for the XNU kernel, is radically different from that on the traditional system, and uses a restricted subset of the C++ as it's the programming language. Uh, just noted that whenever you are designing any system software or the machine level software, 99% of the software uses and the C++ language. There is a main reason behind is this language uses the pointer concept, and the pointer is the programming concept, and which which uses by which you can directly access the hardware address where the value of the particular variable or the particular program is stored. This system is implemented by the Libgen library in the Mac operating system. Some useful features is numerous device families. This is ATA, fireware, graphics, HID, network, PCI, USB, HID, object-oriented abstraction of the devices, plug and play and hot plugging, power management, dynamic matching and the loading of the driver, multiple bus types, database for the tracking and the maintaining detailed information on the instantiated objects, the IO registry, a database of all the IO kit classes available on the system, drivers tracking and so on. So the design principle of this, the whole Mac OS, is the object oriented design. Everything in Mac is an object. Whether in, if I talk about the Linux, everything in the Linux is a file. So each operating system has its own way to uh, solve the particular um, problem or internal design. The retain BSD compatibility is simple programmer interface, easy portability. Portability means whatever program you are writing on the Linux or the Windows, it should work across all the operating system. Though it may have the different settings from the system to system, but it should work. Extensive library of the apps, combine utility via the pipes, and distributed operation, varying network speed, simplified kernel. These are the object orientation, heterogeneous system. These are the main design principles of the operating system. So here I'm going to stop, and my next colleague will be continuing from this slide next onward. Thank you.
Thank you, Pritesh. And hello, everyone. My name is Vinit Sotkar, and I'm going to continue this informative session on the iPhone operating system. Actually, Macintosh operating system is the basic operating system of the Apple INC, and it introduces iOS in 2007, especially for iPhones, and it was called as iPhone OS at the time, and now it is called as iOS. The overall Mac structure is it is actually introduced in 2007. It has some layers like user applications, application level. At the application level, it has Unix operating system, and the basic level is Macintosh microkernel. And microkernel is the system, not a system. It is a small software that needed to implement the operating system. And sorry, and other operating systems are typically user level operating systems, and because of these levels, Mac operating system is quite secure. The second thing is uh, tasks. Here you can see system components which are related to the overall task and overall primitive abstractions. So task, what is a task? First of all, task is a basic unit of programming that operating system controls. So task is a uh, basic thing that programming controls. And thread is the smallest sequence of program instructions that can be managed independently by scheduler. Port is a location. Um, Port is a location used for passing in and data. Port is a location used for passing data in and out of your computer. Message are used for internal process operating by the communication by the operating system for communication. Uh, Memory object, it is a program obtains storage above the bar in chunks of virtual storage. It's called a memory object. Uh, Port set, obviously, as per the ports, it is a set of many ports which are also needed for overall functioning of the operating system. It's depending on the how our operating system defines the tasks. It is design. This unit of operating system may be an entire program or each successive invocation of program, since one program may make a request of programs other utility programs. The utility programs may also be considered task or subtasks. Um, all of today's widely used operating systems support multitasking, which allows multiple tasks to run concurrently. And multitasking is came in the iPhone or operating systems after the in Macintosh after the 10 years of I think it is in 1994. Macintosh is the operating system which came in the market in 1984. So in 1994 it functions multitasking, it supports multitasking. The another topic is process management. In process management, there are the processes which are run using tasks, threads, and there is also CPU scheduling. So first one is a task. Task is actually uh, it depends. Task is actually a bunch of threads. It contains threads, and task is a work to given for something. Work given to operating system or to complete the work is a piece of work. Um, and virtual address space plus port rights. Uh, it contains virtual address space. Okay, threads. Threads are the small uh, uh, threads are the small programs. Uh, Threads are the sequence of programming instructions that can be managed independently by the scheduler. They are running, executing, or waiting states. They're to be allocated by the processor. Considered to be running even when blocked within kernel on page default. Suspended When suspended, neither executing or on a processor nor waiting to be allocated to a processor. It is used to achieve a type of thread level synchronization. Now, CPU scheduling. Sorry. Uh, in the CPU scheduling, it is task and threads. I'm explaining now task and threads together. Uh, New task inherit duplicate of parent memory. Uh, New tasks have several ports. Obviously, new tasks are having several ports. As example, task self represent that the task calls to the microkernel similar to the task name. Another one is tasks are composed of multiple threads. That is, programs can be designed with multiple threads of execution. Another one is tasks threads may be executing on multiple processors. It is increased efficiency of the user layer program, As example, only a thread doing a system call is blocked, not entire task. Okay. So another thing is process management. So in process management, uh, C thread packages. It is user level thread library built on top of Mac primitives. Major influence on POSIX thread standard. uh, Thread control. In a thread control, it create threads and destroy the threads. Waiting threads for specific thread to terminate, then continue the calling thread. Yield means we have to wait, and we have to wait first and go. uh, Mutual exclusion using spin locks is also the included in process management systems. Condition variables like wait and signal, which is a semaphore functionality, it is also contained in process management. There are different thread technologies. Current One of these is Cocoa threads. It is actually programming. It implements the thread using NS thread class. Cocoa also provides methods on NS object for swapping new threads and executing code on already running threads. For more information, using NS thread, you can see that you can also use uh, ns object to spawn a thread. Okay. After that, POSIX thread provide a C-based interface for creating threads. If you are not writing a Cocoa application, this is the best choice for creating threads. The postfix in the postfix interface is relatively simple to use and offer ample flexibility for configuring your threads. For more information, uh, you can see the uh, postfix threads using postfix threads. Another one is multiprocessing services. Multiprocessing services is a legacy C-based interface used by applications transitioning transitioning from older versions of Mac operating system. This technology is available in operating system X only, and uh, should be avoided from any new development. Instead, you should use the NS thread class or POSIX thread. If you need more information on this technology, then we have to study something like a multiprocessing service programming guide. It will give us more information. Now, running thread. Um, Setting the stack size of a thread. Cocoa in operating system and OS X v 10.5 and later, allocate and initialize the an NS thread object. It does not use You should not use detach new thread selector uh, to target or with object methods before calling the start method of the thread object. Sorry. Use the set stack size method to specify the new stack size. That's it. In a POSIX technology, we can create new pthread at attr underscore t structure and use the pthread underscore attr underscore set stack size function to change the default stack size. Then we can pass the attributes to the pthread underscore create function when creating your thread. Another technology is multiprocessing services. In this, we can pass the appropriate stack size value to the mp create task function when you create your thread. In a running loop, we can see that thread from start to end run four default methods, which are time fired, my selector method, customs src method, handle port method, and it they can run one by one in a loop. For this, they need a process input and sorry, they need input sources like port and custom. They also need a time sources and ethernet. Another one is run loop models. uh, these are the preferred run loop models. Mode In a default mode, their name is NS default run loop mode. It's a Cocoa. Uh, KCF run loop default mode. It's a core foundation, and the default mode is the one used for most operations. Most of the time, you should use this mode to start your run loop and configure your input sources. Uh, Another mode is connection. In a connection, its name is NS connection reply mode in a Cocoa. Cocoa uses this method, this mode in conjunction with NS connection objects to monitor replies. Sorry, to monitor replies. You should rarely need to use this mode yourself. Another mode is a model. Uh, its actual name is NS model panel run loop mode in a Cocoa. Cocoa use this mode to identify events instead for model panels. Another mode is event tracking. Its name is NS event tracking run loop mode in a Cocoa also. Also in Cocoa. Cocoa uses this mode to restrict incoming events during mouse dragging loop and other sorts of user interface tracking loops. Um, that's it. And another mode is common modes, like NS run loop common modes and KCF run loop common modes. It's a core foundation, and this is a configurable group of commonly used models. Associating an input source with this mode also associate it with each of the modes in the group. For Cocoa applications, this set includes the default model and event tracking modes by default. Core Foundation includes just the default mode initially. You can add custom modes to the set using the CF run loop add common mode function. Uh, uh, After that is a process manager. We can I'm going to talk on CPU scheduler. Uh, in a process management, only threads are scheduled and tasks are ignored in CPU scheduler. Uh, in it, dynamic thread priority number is 0 to 127. The lowest priority thread is one with the most recent large CPU usage. Priority sorts thread into one of 32 global run queues. Uh, Per processor queues used for locality specific threads, example device drivers. There is no central dispatcher here. Processors consult run queues to select next thread, the local queue first, uh, then the global queue. uh, Optimization: the thread time quantum varies inversely with the total number of threads but constant over the entire system. uh, Now exception handling. It's implement the global cross task exception handling system. It works on a distributed system because it's implemented via RPC messages. It used to emulate BSD style signals, and it supports execution of BSD programs, and signals are not suitable for multi-threaded environment. Now, inter-process communication. Macintosh overriding principle is to be a simple extensible kernel concentrating on communications facilities. A universal communication mechanism between all objects in the system is in Macintosh. Uh, the location independence is also included in it. Automatic addressing is one of the feature. Now, isolation between objects because all messages pass through the kernel. It allows isolation between messages to pass the message to the kernel. Secure communications via port writes. Uh, Here we can communicate securely via port writes. Uh, uh, and I can describe some points here. It needs capability to communicate on a particular port. Many senders, iris like I receivers, uh, transferable write must be transferred via IPC so the kernel can track the transfer. Now, inter-process communication, port and port sets. First one is ports. Implemented as ports are implemented as a protected bounded queue in a kernel has a unique global name, system calls. Uh, has a unique global name. Now a system calls allocate a new port in task. Uh, it give the task all access rights. It's deallocate tasks access rights to a port. It get port status. It create a backup port to inherit the receive right when the executing port is deallocated. Now port sets. A group of ports in the same task is called as port sets. It is used for a single thread as an incoming queue processor. Example as a Unix select poll system calls. A port may be a number of one set at a time. Now match ports, Macintosh ports. Uh, Here communication channels and object reference mechanism. Uh, we can see in this methods on kernel objects invoke Y messages, uh, and it's enable the thread to send data to another thread in a controlled manner, uh, like a kernel protected implemented as a bounded queue. Now then, send and receive rights. Only one task with receive rights. It has only one task with receive rights. It can be multiple with send rights. Uh, Now sending receive rights to another task causes ownership or receive rights to change. Ports are ports are location independent. Here, sending message to a port will result in the receiver task getting the message, independent of where receiver is on network. Okay. Task and corresponding port can be migrated to another computer with the same machine architecture. Inter-process communication using messages. In a messages header plus one of the more data objects are used. Header contains destination port name, reply port name, and message length. Inline message data contains simple types port rights. Out of line data contains pointers. In it via virtual memory management and uses copy on write and having a sparse virtuality memory. That's it, friend. One of my colleague Mohan will continue this informative session. So thanks. We'll see you soon. Thanks. Bye. Bye bye.
Thank you, Vinith. I'm Mohan Kumar Undavelli. I want to speak about interprocess communication. It is a set of methods for exchange of data among the multiple threads in one or more processes. The functions of these are local independence and transparency. Net message server message between the host and used when receiver port is not on the kernels and computer by providing network wide name service and network protocol interface and allows many implementations. Mac 3.0 IPC for Norma multiprocess systems directly in the kernel and supports info in a single system across smaller ones. Synchronization using IPC. IPC based synchronization port uses synchronization variable since receiver message is called as a wait signal and send message is a signal which can activate the mode of it. Only works natively for threads within the single task because one receiver task is allowed on a single port only, and that send receives and messages between the tasks. Memory management IPC memory there is a Mac connects the memory management and communication in the IPC by allowing each to be used in a implementation among each other. Memory management using IPC based on the memory objects and ports which are represented by ports IPG messages are sent to those ports to request operation on the object. IPC using memory management techniques are the messages are passed by moving pointers to shared memory objects. The virtual memory remapping to transfer larger contents and prevent the copying wherever possible. Programmer interface system call levels, BSD elimination in uh, during the system call levels, we can call kernel by uh, BSD elimination in kernel in 2.5 and elimination libraries and servers in user space. Upcalls made to libraries in task address space or server. C call thread package. C language interface to match threads primitively. Interfaces subgenre called IMG, MIG or RPC calls. Interrupt supports for the devices. The interrupt is that we, which can be by memory mapping or direct microkernel support. Math IO system, device management, memory objects used for mapping devices to the memory are handled in user level processes. Non-memory mapped devices handled in the microkernel, not in such as memory mapping devices or something. um, Math IO input output system, device management, memory objects used for mapping devices to memory handled in the user level processes. Non-memory mapped devices handled in the microkernel. Location transparent device management, whereas in location transparent device management, devices are memory objects. The ports in these devices can be accessed by any task with appropriate rights. Math IO system, device management, memory objects used for mapping devices to memory handled in user level processes. Non-memory mapped devices handled in the microkernel. Location transparent device managements, the devices are in the main memory objects. Ports on these devices can be accessed by any task with appropriate rights. User level IO input output can increase the performance by avoiding the data which is copied between the kernel and the memory space and user level micro memory space. In the experiments, the we can see that user level device management is at least as good as kernel level. Functionally grouped devices, the devices which having devices such and screen, console, disk, tape, serial line and ethernet. Each device layers of a chip independent code. Minimal devices dependent code in microkernel. Example, the serial kernel in serial liner driver. We can see devices which are independent of their components like open, close and read, write can be start, stop, and these are independent of their device independent, and device dependent on only on operation that can manipulate within the register directly are called as a device dependent. Microkernel, basic process of interrupts before handling of using user level, such as some register state in shared page or disable interrupt for the device vectors device interrupts to the applications threads. The microkernel can be helpful. Microkernel basic operations of user level thread. When it runs, it invokes interrupt routine, like when we run a thread like having an infinity or something, it can invoke the driver interrupt routine. After processing the thread re-enables interrupt in the device. Specialized versions of math kernel. Math kernel is a general process which is machine dependent features may need to be generated, such as norma, no remote memory access. Multi computers which fast interconnect hardware. Need for the faster inter-process communication. Solution: Math 3.0 implements functionality similar to the net message server directly in kernel and provide as efficient as the microkernel by connecting to internode. Math Basics based Unix, MS DOS, and Mac OS written as a user level applications. Systems call to these operating systems RPCs from user level applications to user level operating systems running on the Mac, which can be run like this. And input output on in the user level operating systems handled in the part by the memory objects. Device such as Ethernet SCSI is a memory mapped into the user level operating systems. Math microkernel based does basic level process of device interrupts first by passing a indication of interrupt to the thread in a user level of the operating system. By this, we can handle the interrupt in it. Some issues which can be seen in the Mac OS are how how do you deal with an hardware in a user level OS. Operating system provide interfaces and management of hardware resources also. Example: interrupt management and device drivers. We can have a question that can a user level OS which can run in user space deals with an device or not. But what about the efficiency and about the things of the what microkernel do regarding the efficiency of the OS Mac? A microkernel seems to be optimized operating system design. The microkernel by the layered approach, it can make the OS system more efficient. But while messaging to microkernel, then messaging to Unix application reduce the efficiency too much. Is the Unix or other user applications OS really a user application? Is this also this is also a question which can be um, occurred when we run the OS Mac. Are the users going to read the additional operating systems? Are different types of users really the levels of abstractions in the OS design also file systems, and the file systems contents are organized into files and directories, which can be the files are stored in a data which can be shown as below. We can see it on the screen. And what is the file system? It is that a file system contents are organized into files and directories. The are organized in the files and directories as file A, file B, and file C. It can be shown on the screen with different colors and everything. What is a file system? Provides an abstract view of data which is stored in a storage device. File system contents are organized hierarchically into files and directories also. The storage of file systems can be stored as data files, applications, and the files associated with the OS itself. And remaining part of this will be continued by my friend Nahid Rahman. And thank you.
So thank you, Mohan, for your nice speech. Today we are talking about Mac operating system. I am Mohammed Naid Rahman. I will continue where Mohan left. So he was talking about Mac files. Actually, there are two types of Mac files. One is data fork and another is resource fork. So data fork is generally actual data, only meaningful part of a Macintosh file on a non-Macintosh system. And collection and the attributes are the resource fork. So example would be the text. Text would be the data fork, and the embedded image would be the resource fork. So there is something called Finder in Mac OS. Is our savior. We can use this one to for the default file manager, explore files and launch applications as well. So Mac file systems would be categorized in two types. One of them is local file systems and another is network file systems. For the local file systems, usually it's attached storage like ASFS plus, HFS, NTFS, UDF, and UFS. For the network file systems, it uses file on other computers of same network. Apple filing protocol, FTP file system, NFS. There could be so many other protocols to use the network. So there are some pseudo file systems. So what is pseudo file system? It provides file-like views of non-file information, no conventional file store, no dedicated disk block, access kernel variable and data using file system application interfaces. Examples would be like CDFs, DEDFS, DevFS, etc. And another thing is Apple's cluster file system, which is shared on SN file system or family of XN product, we can say. So local file system, one of them is Macintosh file system, which is also abbreviated as MFS, introduced with Macintosh computers in 1984. Files is stored in a single directory, which is called flat file system. So, and the illusion of hierarchical view using the Finder, we already talked about the Finder. So it first introduced the resource fork and the metadata. So resource fork was used to store structured data, and metadata was used to support graphical user interface of macOS. So in 1984, it was used to store files only 400 kilobyte of floppy drive, and that's it. So let's now talk about another category, which is hierarchical file system, HFS. It was introduced later on 1985 with macOS version was 7.6.1. It was used to support Macintosh fast hard disk drive. It used B-tree based catalog file. It replaced 16-bit integer by 32-bit integer. So HFS design was basically some sort of logical block, divide volume into 500 kilobyte each, and the allocation block groups together in some logical blocks, one allocation block for each file. 16-bit value to address allocation blocks. So number of allocation would have been 2 to the power 16 minus 1. So 5 structures make up HFS volume. So first structure with the boot block. So boot block is just block 0 and block 1, only two numbers were used, and the name of the system and shell files. The second structure to make the HFS volume was master directory block, which is logical block 2, date and time volume created, location of volume bitmap and size of allocation block. The third one was volume bitmap. It was called logical block 3, which allocated blocks and is represented by a bit in the map. Fourth one was the extended overflow file. It's also used the technique of B-tree, which allocation block is allocated to which file. And for the catalog file, it contains the record of all files and the directories. It also used the same techniques as B-tree. So what is the limitation of HFS? It has some limitations. So for the catalog file, there is no multitasking and very lack of reliability. So that's why they introduced HFS Plus. It was introduced in 1998, and the macOS version was 8.1. It replaces HFS. So they introduced some sectors called logical blocks, 32-bit value to address allocation blocks. So number of allocation blocks now become 2 to the power 32 minus 1. Okay, so let's now talk about some HFS Plus design. So 9 structures make up HFS Plus volume. So initially some boot blocks like sector 0 and 1 like the previous one. Now they introduce volume header. It's called master directory block. It's named sector 2. Volume data size of allocation blocks and use timestamp. And another one is allocation file. It's use bitmap and catalog file for a B-tree, and extends overflow file, attributes file. Attributes file contains like inline data attribute, fork data attribute, extension attribute records, and so on. Start a file, alternate volume header, and the last, which is reserved for Apple, used during the computer manufacturing process. So thank you for listening to us, and we hope you guys enjoyed our slides and the video. So see you soon, and have a nice time. Thank you again.
कट करून टाकू रे कट करून टाकू तेवढा part.